Hi guys, if you are viewing my channel first time, please subscribe to my channel for more updates on machine learning. Today we are mainly discussing about an extreme gradient boosting or XGBoost. It is one of the supervised learning technique in our machine learning. By using supervised learning technique, the prediction can be made. Okay, here the training and also prediction mainly follows the boosting technique. That's why we will discuss background of the ensemble techniques here. Ensemble techniques are two types: bagging or bootstrapping aggregation, and second one is boosting. Bagging or bootstrapping aggregation is a parallel process and boosting is a sequential process. Okay, let us take the 1000 records as my data set, and this 1000 records, random 700 records I have taken for this original training data. This original training data we are dividing into the multiple data sets. Data set 1, random 400 records we have taken from this original training data 700 records, that we are mentioning it as data set 1. Similar way, random 420 records we have taken from this original training data, that we are mentioning it as data set 2. Similar way, data set t minus 1, data set t. Okay, once we have the all the data sets, then we need to build our model, either classifier or regressor. For example, if my target data is categorical or binary, then we need to use the classifier. For example, if my target data is continuous, then we need to use the regressor. Okay, similar way, we need to, based on our data, we need to build our model, either classifier or regressor. Okay, similar way we need to build our classifier or regressor. Similar way we need to build our classifier or regressor. Then finally we need to combine all the results for our prediction. For example, in case of classification, for example, let us assume we have four classifiers. Okay, for example, classifier 1 I got the output true. For example, classifier 2 I got the prediction true. Classifier 3 I got the prediction true. Classifier 4 I got the prediction false. Okay, which is having highest word, that I am selecting it as a my prediction. This is in case of classification, 2 is my prediction. Similarly, in case of regression, okay, in the regression 1 output, for example, 10, regressor 2 prediction 20, regressor 3 prediction 30, regressor 4 prediction 40. Okay, here we need to combine all the results, we need to add all the results and divide by 4. Okay, we need to aggregate all the results, that we are taking it as a prediction. Okay, this is the way we are training and also prediction by using this Banger bootstrapping aggregation. Mainly random forest follows this Banger bootstrapping aggregation. Okay, now we'll discuss the boosting technique here. Okay, here in the first model I'm just passing the 10 records. Okay, it was classified 3 exactly, but 2 are misclassified as a red. Okay, that's why this I want to target in the next iteration. That's why I'm drawing a line here. These two misclassified records in the first iteration, that I'm classifying exactly here, but other three records classified as red. Okay, these three are misclassified in the second iteration. That's why I'm drawing a line here. Okay, here in this case, 5 blue records I classified exactly, but other red records are classified as blue. These 4 are misclassified in the third iteration. Okay, for example, if I calculate the efficiency of this model, let us assume 30%, and the second efficiency of the second model is also 30%. Third model also efficiency is 30%. If I am just combining all the models, then I will get the highest prediction. Okay, for example, here these three are weak learners, then I am just combining together, I am forming a strong learner. Okay, this is a mainly boosting technique, the mainly process of the training and also prediction. Mainly XGBoost algorithm can be used for both classification and regression problems. Okay, today we are mainly discussing about one regressor problem we'll take, and we'll see how we'll train and also how we'll predict. Okay, here I have taken one example data set, experience and salary. X is my independent feature, experience is my independent feature, and salary is my dependent feature. Okay, XGBoost, I'm just the first step. We need to follow all the steps one by one. Step 1, calculate the base model residual. For example, XGBoost always sequential process. Okay, X and Y. For example, this independent and dependent variable I am passing to the first decision tree. Then I will get the prediction H1. For the second decision tree, we need to pass the final residuals. For example, actual is my y minus h1 prediction. Okay, this actual minus prediction error I need to pass the as a target in the second decision tree. This is my target is the error, and independent feature as it is. Okay, just similar I am just building my model, and we'll get the prediction h2. Similar way, this independent feature as it is, but this dependent feature actual is y minus h1 minus h2, actual minus prediction. Okay, this is my error I am passing to the second decision tree, third decision tree. Then I will get the prediction as h3. Okay, this is the way we are training and also get the prediction. Okay, we need to average all the outputs, then we'll get the final prediction. Okay, here in the first step we need to calculate the base model residuals. Okay, base model, it will give the prediction as mean value. For example, if I calculate the mean for the this actual data, then I will get the prediction. For example, I need to add all the actual data and divide by 6. We have 6 records, divide by 6, then just I calculate the mean. That mean I am just considering it as a prediction for every record, 48, 48, 48. Okay, if I calculate the error, actual minus prediction, this is my actual data minus prediction, I got minus 8, 42 minus 48 minus 6, 54 minus 48 6, and 42 minus 48 minus 6, 60 minus 48 12, 50 minus 48 2. Okay, I got the error. This error we need to pass to the next decision tree. I have the base model, I got the mean prediction, from that I got the error. Okay, from this error, this independent feature I need to pass to here, and also error as a target in the first decision tree. Okay, this base model I just calculated, and the second model, right, we need to pass independent feature, one target is as a error. Okay, here I am splitting the tree based on our threshold. For example, I have taken, I don't know the threshold for exact data, that's why I'm taking the initially for my threshold. Okay, less than or equal to 4, I'm considering it as one of the split, and greater than 4, I'm considering another split. Okay, this is my another leaf, this is my first leaf. Okay, here I am splitting the tree based on our first record. I don't know the actual threshold, that's why I'm taking 4 as my threshold. Okay, less than or equal to 4, I'm splitting the tree. Okay, less than 4, I got only the one record left side. Then the right side, I have only remaining 5 records. 5 records are right side. Okay, this is the way I have splitted our decision tree based on our independent feature. This is the second step. Next, we need to calculate the similarity weight. The third step, we need to calculate the similarity weight. Okay, to calculate the similarity weight, the numerator is always sum of the residuals whole square. Denominator is number of residuals plus lambda is constant. Okay, let us take the one in our case. Okay, similarity weight I am calculating with one residual. Okay, how many residuals we have? Only one residual, minus 8. This is my residuals whole square divided by 1. 1 means number of residuals in this leaf, only one residual, 1 plus lambda is 1. Okay, just I calculated using this formula, similarity weight formula, then I got 32. Okay, similarly we'll calculate the similarity weight for the second leaf. Okay, we have how many residuals? We have 5 residuals, minus 6 plus 6 minus 6 12 6 2. Okay, these are the 5 residuals whole square. This is my numerator I got, and the denominator I have 4 records. Okay, 3 4 5, here we have 5. Okay, here we need to consider 5, 3 plus 5. Okay, here we need to calculate 5. Okay, here 5 residuals I have, lambda is 1. Okay, similar way I calculated, I got the similarity weight is 10. Okay, now we need to calculate the gain for this model. Okay, now we'll calculate the gain means we need to sum all the leaves similarity weight minus similarity weight of the root node. Okay, here I just I7 means 32 plus 10.6. Okay, just I added these two leaves similarity weight, and I need to minus our similarity weight of the root node. Okay, now if I calculate the gain, I got the 42.66. Okay, if I calculate similarity weight for the root node, how we will calculate? Just we need to take all the records. For example, minus 8, minus 6, plus 6, minus 6, 12, and 2. We need to take all the 6 records, whole square divided by 6 is number of residuals are 6 plus 1. Okay, here I calculated the similarity weight, I got 0. Okay, from this we can calculate gain easily. We need to sum all the leaf similarity weight minus our root node weight. Okay, now I got the weight for this split. Similar way we'll try to split using the second record. For example, I am considering this as my threshold, less than or equal to 4.5. Okay, these two records I am taking for the left split, remaining 4 records I am taking for the right split. Okay, let us calculate again our similarity weight as well as our gain. Okay, here I am calculating the similarity weight using the two residuals -8 -6 whole square divided by number of residuals are 2 plus 1. Okay, okay, lambda. Okay, just I calculated the similarity weight for this sleeve using the this two residuals. I got 65. Similar way I am calculating the similarity weight for the second leaf. 6 minus 6 12 2. Okay, 4. Okay, whole square, all residuals we need to just sum it and whole square divided by 4 residuals we have plus 1. Okay, lambda value is 1. Okay, similar way I calculated the similarity weight for this sleeve, and similar way we need to calculate it is as it is as first split. Okay, here also I am just doing the all addition of the all the residuals. -8 -6 6 12 2. Okay, divide by 5. Okay, here we have 6. Okay, sorry, here we have 6 number of residuals are 6. Okay, similar way I just calculated, I got 0. Okay, now I have the weights of all the leaves and also root. Okay, so that I can just add the these two weights, leaf similarity weight minus root weight. Okay, similar way I calculated like this. Okay, 65.33 plus 39.2 minus 0. Okay, similar way I calculated, I got 104. Okay, if I see the, for example, if I am using the first threshold, I got the gain as 42. If I am using the second record as my threshold, I got the gain as 104. Okay, here gain is more. Okay, this is a better split. Okay, this is my better split. Similar way we need to go further. For example, I can select my threshold 5, so that these 3 records I can take to the left hand and these 3 records I can take to the right. Okay, similar way we can calculate the gain. And for example, if the gain is for example this better than this 4.5 threshold, then we need to take that split as our reference. Okay, this is the way we need to split our tree as per our independent feature. Okay, here the splitting also is done, and also we need we calculate how to calculate the and also we calculated the gain. Okay, here next we'll see the prediction. Okay, I calculate the similarity weight. From the similarity weight we calculate the prediction. Now we'll calculate the output of each and every leaf. For example, my data is less, x is less than 4, then I will come to this leaf. My prediction output is -8. For example, similar way we'll calculate for this output. Okay, here for example my independent feature, for example 5, it is greater than 4, then I will come to here, then I need to average all the residuals. Okay, here I am just summing all the residuals and divided by 4. This is my output of my root node. Okay, then we'll calculate the prediction of the first model. Okay, model 1 prediction. Okay, here I have calculated the prediction of the first record. Okay, 48 is my first record. This is a formula, new prediction, model 1 prediction. Okay, model 1 prediction is 48. This is a base model prediction, plus learning rate is constant 0.1, multiply output of the first leaf. For example, my record is 4. 4 means it will come to here. What is my output? -8. -8 I have taken here. I8 means -8. Okay, similar way I just calculated, I got the prediction as 47.2. Okay, here the actual is 40. My first model prediction is 48. Okay, I am reduce to 47 using the second model. Okay, a similar way if I go further, I'm able to achieve the whatever the target and also prediction also matching. Okay, if I want to go further iteration, for example, let us assume after 10th iteration my actual and prediction are both are matching, then it is a good model. Okay, that way we need to choose how many number of models we need to choose, and we need to get the actual and prediction as it is. Okay, here I got the prediction for the one record. Okay, for example, we have 10 models. How we'll calculate the prediction? For example, we know already this for the multiple models how to calculate the prediction. For example, model 1 prediction already we are aware of 48 plus sum of learning rate for the first model multiply output of the first model plus learning rate of the second model multiply output of the second model plus learning rate of the third model multiply output of the third model. This is the way we need to calculate our final prediction for the multiple models. Okay, here we calculate the one single model, we calculate the prediction. Similar way we need to expand summation of learning rate multiply output for the multiple models. Okay, this base prediction always constant. Okay, this is the way we need to calculate the prediction, and we know how to train our model and also how to predict. Then we will build our XGBoost regression using the Jupyter notebook. Okay, here I have the one sample data set here. Here years of experience is my one column and salary is my another column. Okay, here X is my years of experience, Y is my salary. Okay, here I am dividing into the two parts: train data set and also test data set. Okay, if it is my X column, I am just mentioning to the X train. If it is my Y column, Y train. Similar way, if it is my X column, X test. Similar way, if it is my Y column, Y test. Okay, I just divided into the four parts whatever my data set. Okay, for example, if I want to train our model, we need to pass X train and Y train to train our model. If I want to test our model, we need to pass the X test, then we'll get the Y prediction. Then we'll calculate the efficiency between the what is my actual data and also prediction data. Okay, similar way we'll go to the Jupyter lab. Here XGBoost regression. Here I am importing the libraries. Import pandas as PD. Okay, this is my alias name. Okay, this is my pandas. If I want to access any data set, then we need to use pandas. Data set equal to PD is my alias name of pandas. Read CSV is a method for to access our CSV. Here salary.csv. Here I am accessing the same data set. Okay, same data set I have accessed here. Dataset dot head, it will display the first five records: 1.1, 1.3. Okay, it is similar to the whether we are accessing the same data set or not. We can identify by using this head command. 1.1, 1.3, same data set I am accessing it here. Now we will mention what is my X and what is my Y in our data pre-processing. Okay, here I am just filtering my from this object. I am filtering only years of experience. One column I am mentioning it as X, and salary is my Y. Just I am printing what is my X and what is my Y. Okay, years of experience 0 to 29, 30 records. Similar way salary. Okay, now right now we have the X and Y. Then we can split four parts as we discussed in the initial. Okay, here just I am splitting our data into the four parts by using train test split. Train test split. Here I am passing my what is my X and what is my Y. I am just passing to here. And here I am mentioning train size is 0.5 means, and also test size also 0.5. Out of 30 records, I am taking 15 records for the training and remaining 15 for the test data. Okay, next random state is 10 means. Okay, always we should initialize with something, otherwise we'll get always different prediction in each and every execution. Okay, here I got the four parts: X10 and X test, Y10 and Y test. Here I got the four parts. Similar way here. Okay, by using this method, we can just split according to our requirement. Okay, here from XGBoost import regressor. Okay, I want to execute using the XGBoost regressor. Okay, here XGBoost is my object. I am accessing my class XGBoost regressor. Okay, here XG, this is my object dot fit. I am accessing one of the my method fit. I am just passing the X10 and Y train. If I want to train our model, I need to pass X10 and Y train to train our model. Okay, my model training is done. Here we need to just remember lambda is the one we are using, and also learning rate 0.3. As in our initial example discussion, we have used learning rate as 0.1, and also this lambda we as it is we used 1. Okay, and also Y prediction. Actually, this is my object dot prediction. Okay, prediction I'm using one of the method. I'm just using my object as it is. Dot predict is my method. I'm just passing the X test. I'm just passing my X test, then we'll get the Y prediction. Okay, now I got the Y prediction. So I have the Y test and Y prediction. I have Y test and also Y prediction. By using these two, we can calculate the accuracy. Okay, here from scalar matrix input mean square error, R square score. MSC equal to mean square error. I'm just passing the Y test and Y prediction. Okay, here I got the MSC R square. R square score, this is the method. I'm just passing the Y test and Y prediction. I got the R square score. Similarly, if I want to get the RMSC, just I need to apply the square root to the MSC. Okay, just I am applying the one of the math function from math input sqrt MSC. I am just applying. I will get the RMSC. Just I am displaying the MSC, RMSC, and R square score. Just if you see here 0.91 is my R square value. That means 91 percentage of efficiency I got by using this XGBoost regressor. Okay, by using our XGBoost we have trained and also we got the prediction. Okay, mainly this gamma is one of the hyperparameters we are using in our XGBoost. For example, I am choosing my gamma value is 100. Okay, for example, I got the gain of 100 104. If my gain is greater than gamma, okay, we are not removing this leaf. For example, if my gamma value is more than 104, then we need to cut our this leaf. Okay, this is the way mainly this hyperparameter is used for the this removing our leaves. Okay, thank you friends, thank you for watching.